So for the variance, I'm actually going to write the formula over here on the side, and you'll see why in a second. So our variance formula is going to be given like this. Variance we call s squared. And our variance is going to be equal to the sum of x minus x bar squared over n minus 1. So as you can see, we have a little bit more going on here than we did in our mean formula, but it's less complicated than you might think it is to actually find the answer here. So what this formula tells us is that s squared is our variance, sigma means sum, like it does in the mean formula. This whole expression here, x minus x bar, that's going to be our deviations. And you can see when we subtracted each of the different, the mean from each of the different observations, we got something called x minus x bar. So that's what's appearing right here. We're subtracting the mean from each of our different observations. And then the final component in our variance formula is n, which is the total number of observations again. So what this variance formula is telling you to do is to find the deviations in your sample. So find all these different deviations that we just found in the last example here. Then square them. So take each deviation and square it. Add them together, that's what sigma means, and divide by n minus 1. And the nice thing is we've actually already done our very first step here. So the first thing that you want to do if you're looking for the variance is to find all the deviations. And we got that. So here, we're going to start with our list of deviations, and we're going to go from there. We need to add up our squared deviations. This means that the next thing we need to do is square the deviations that we just found. The reason that we square them before we add them up is what we saw in the last slide, where if you add them all up before squaring them, they always turn into 0. But if you square them, it means that they're all positive and you're going to get some number that's not 0. So you can do something with that number. But that's why we do this squaring part here. So for each of these different deviations, we're going to multiply it by itself and get some number. So here 0.5 squared comes out to 0.25, and that's going to be x minus x bar squared is 0.25. And so I'm going to write out x minus x bar squared for each of these, so negative 0.5. Once you square it, the negative sign goes away, so it becomes 0.25. Negative 1.5 squared is 2.25, and so on. All right, so now we have a list of values that we can refer to as x minus x bar squared. So in looking at this formula here, we're working our way towards having all the pieces that we need. So here this is saying take the sum of your x minus x bar squareds. Here we have a whole bunch of x minus x bar squareds. That means our next step is going to be to add them up together. And so we're going to add up everything in this column to get what's on the top here, which is the sum of x minus x bar squared. When we add all of this up, we get 25. So this 25 here is going to be equal to the sum of x minus x bar squared. And as you can see, with each of these steps, we are building our way towards this total formula here. So now we have the whole top of our equation, the whole numerator. In order to find the variance, we're now going to take this value that we have, 25, and divide by n minus 1. So this is our sum of x minus x bar squared. We're going to take that, sorry, I keep going out of the view here. We're going to take this 25 and we're going to divide it by n minus 1. So to get the variance here, we're going to do 25 divided by 12 minus 1, and that's equal to 25 over 11, and that comes out to about 2.27. So that's it, we have our variance. And what this means is that our variance, or sum of our squared deviations over a total number of observations is equal to 2.27. One thing to notice here, though, is that the units are arrests squared. And what we have here is a measure that's telling us that if you find all the deviations, square them to get rid of those negative signs, add them up, and then divide by the total, you have a number that's equal to 2.27 arrests squared. And you'll notice that that's not really a very useful or intuitive measure of anything, right? First of all, what's an arrest squared? Nothing. And second of all, we have these squared terms here, so we sort of have the distance away from the mean, but then it's squared, and we have some sort of average of the squared ones. But it's not really that useful in terms of interpretation. And because of that, we have one more formula that we're going to look at that's going to give us a more easy to interpret measure of variability that's not relying on this kind of weird squared term. And that's going to be called our standard deviation.